Welcome to qnawire.
Okay, Chapter 7, Section Problem 36. The question is, consider the unbalanced equation for the neutralization of acetic acid, and shown as HC2H3O2 plus BaOH2, and it goes to water plus BaC2H3O2. Okay, so we're supposed to balance this thing. Now, what I see when I look at this is I see this C2H3O2, which is the acetate of this is acetic acid. This is acetic acid. Well, then once you lose that proton, then it's acetate. So this is like hydrogen acetate, and that's repeated over on the other side. And that's this is a double displacement reaction actually between the hydrogen and the barium. So you can treat that whole thing as a unit. And once you kind of recognize that, it actually kind of simplifies this whole thing. So let me show you what I mean by that. So if I was going to write this, it could be like H acetate, AC. We'll say that's aqueous. Plus barium hydroxide. And this is going to go to water. And again, this barium, but again, to kind of simplify things and save myself a lot of, headache, I'm just going to treat that as an ion because that's what it is. Okay, and then we've got two of those. So this already looks a little bit more manageable. So now let's balance this thing. Okay, so let's look for things that are different. The bariums are the same on each side. We do have different amounts of that AC, of that group. Okay, I've got 2 on the right, so I have 1 on the left. So if I multiply by 2, now these are balanced. And then I move on to the thing that I changed. So the hydrogens, so I've got 2 on the left, 2 on the right. That's fine. Oxygen, this is the next thing that's different. Maybe. Okay, so I've got 1 on the right, 2 on the left. So I actually need to multiply this whole thing by 2. So now this is 2, and this is 2. So what did I switch when I multiplied that? The hydrogens, right? Okay, so now I need to do the hydrogen. Okay, 4 on the right. On the left, we've got 2. Let me see if I can. We've got 2 from the hydroxides. And then on the left, we have 2. And wait, now this is balanced. See how that just worked? Okay. Barium, let's see. 1 on the left, 1 on the right. So we can already see how that helped. Okay, so now we've got our balanced equation. Now we need to solve the second part of the problem. Okay, so what the question was is how many moles of barium hydroxide are required to completely neutralize 0.461 moles of that acetic acid. Okay, so how do we do this? We need to, let's see, 36. I thought I had some calculations already done. I don't. Let's do this. How many moles of the barium hydroxide? Okay, so so our starting point is this number of moles of our acetic acid, right? Like when we look at an equation like this, what the balanced equation gives us is a whole bunch of like proportions. Like we know that 2 equivalents of this will react with 1 equivalent of that. And a lot of times when you see a question and you need to find something to hold on to, you need a number. You can't have like a ratio. Okay, so in this problem, the number that we're starting with is this 0.461 moles of our acetic acid. Okay, so that's the starting place. Now, it's asking us to get somehow through some sort of conversion or a set of conversions to how many moles of our barium hydroxide. Okay. So what we really need is a way to convert the moles of acetic acid to moles of barium hydroxide, and that's what our balanced equation does. Okay, so let's see. If we put acetic acid down here, for every 2 moles of acetic acid, according to our equation, that's going to give us 1 mole of OH2, right? Yeah. So it's 1/2 of that. So it's going to be 0.231. Now it's important if we're thinking about significant figures here. Obviously, the right number, or it could be said that it would be 0.2305, but you have to retain the same number of significant figures. So that's why we round back up. So anyway, I hope this helps. You figure out these kind of these kind of problems, because a lot of times it's understanding the process of how to think through these questions. And there you go. Good luck studying.